Rain, snow, hail, seemingly different forms, but ultimately the same thing, water. It's so obvious, isn't it? When we say it's raining, we're describing something so ordinary that we often don't even notice it. But you know what? All it takes is a glance beyond our skies and into space to discover that rain doesn't always mean water. What would you say if I told you that on Venus it rains sulfuric acid? Or that on Titan, Saturn's moon, droplets of methane fall from the sky? And here's an even wilder idea. Imagine diamonds falling like snow on Neptune. These things really happen. And while rain on Earth might sometimes be annoying, after hearing what I'm about to tell you, you might just start appreciating it in a whole new way. Let's start with the hellish planet of Venus. Venus, rain that would destroy any umbrella. Venus, Earth's closest neighbor and a place that could serve as the setting for the most terrifying science fiction film. Temperatures? 460 degrees Celsius, 860 degrees. Hot enough to melt lead. The atmosphere? So dense that the toughest earthly probes survived only a few hours there before literally breaking down under the pressure and heat. And what falls from the sky? Sulfuric acid. Not gentle water droplets, but corrosive acid. Imagine standing on Venus's surface, which, by the way, is impossible since you wouldn't survive even a minute, and looking up. From the clouds, droplets fall that would burn through any material we know. Luckily, though luckily might not be the right word, these drops never reach the surface, evaporating in the planet's hellish heat. But there's an even stranger story. On the peaks of Venusian mountains, scientists have discovered something resembling snow. Not the kind you'd find on a crisp winter morning, but likely lead sulfide or bismuth sulfide. Substances that behave like ice under these extreme conditions. Fascinating, isn't it? Venus is a planet where rain is more of a nightmare than a natural phenomenon. Titan, a methane world that resembles Earth. Now let's travel much farther to Titan, Saturn's largest moon. Titan is one of the most fascinating places in our solar system. It looks like an alternate version of Earth. It has an atmosphere, rivers, lakes, and even seas. But there's one detail that changes everything. Titan doesn't have water. Instead, it has methane. On Titan, methane behaves just like water does on Earth. It evaporates, forms clouds, and falls as rain. Imagine a landscape where the sky has an orange hue, rivers flow like streams of gasoline, and lakes resemble puddles of kerosene. The largest lake, Kraken Mare, is about the size of the Caspian Sea. However, rain on Titan is rare. Seasons change there once every few dozen Earth years, so a methane rainstorm is something truly extraordinary. When it does rain, it's a torrential downpour capable of completely reshaping the moon's landscape. You could say Titan is like an alternate Earth, but in methane mode. Io, the moon of volcanoes and Sulfurio, is one of the strangest moons in our solar system. It orbits Jupiter, and its surface looks like something an artist would create using only shades of yellow, orange, and red. It's a place brimming with energy, quite literally. Io is the most volcanically active body in the solar system. Volcanoes on this moon can eject gases and particles up to 300 kilometers, 186 miles high, enough to reach far beyond Earth's atmosphere. Imagine eruptions so powerful that they can be observed with telescopes from our planet. But what about precipitation? Well, the sulfur and sulfur compounds ejected by Io's volcanoes eventually fall back to the surface. You could say that on Io, it snows sulfur snow. This sulfur, mixed with other chemicals, creates unique formations on the surface, something resembling yellow-red landscapes. If you were to stand there, which would be impossible due to the lack of atmosphere and deadly radiation, you'd feel like you were in a fiery inferno. What's fascinating is that Io's volcanoes are powered by tidal forces. Jupiter's gravity, along with its other moons, pulls Io in multiple directions, literally heating its interior. It's like a constant massage, but instead of relaxation, it creates colossal volcanoes. Interestingly, the material ejected from Io doesn't just stay there. Some of it escapes into space. forming a torus-like ring around Jupiter. This giant ring of sulfur and oxygen particles interacts with Jupiter's magnetosphere, creating stunning auroras on the giant planet. Neptune and Uranus. Diamond rain. Now let's move to the ice giants. Neptune and Uranus. These planets are true masters of mystery. They're distant, cold, and seemingly tranquil. But what happens inside them is extraordinary. Imagine massive storms traveling across their surfaces. On Neptune, some of the strongest winds in the solar system occur, reaching speeds of over 2,000 km/h, 200 mph. These winds shape the atmosphere, creating clouds primarily composed of methane. But what happens deep within these planets is even more remarkable. Under immense pressure and temperature, methane breaks down into carbon and hydrogen. The carbon doesn't remain gaseous, but instead clumps together into crystals, forming diamonds. Yes, actual diamonds. These diamonds fall toward the planet's core like rain, eventually merging into diamond oceans under even greater pressure. Can you even imagine such a phenomenon? Picture a sky filled with glittering crystals, shimmering like stars before vanishing into the depths of a gas giant. In a sense, Neptune and Uranus are cosmic diamond mines, though no spacecraft will ever reach deep enough to retrieve these gems. Interestingly, scientists have tried to recreate Neptune's and Uranus's conditions in Earth-based laboratories. And it worked. Miniature diamonds were formed, confirming that diamond rain on these planets is absolutely possible. WASP-76b, rain of liquid metal. WASP-76b is one of the most extreme exoplanets ever discovered. Located about 640 light-years from Earth, its conditions are straight out of a nightmare. This gas giant is tidally locked, meaning one side always faces its star, like the Moon does with Earth. This results in eternal day on one side and perpetual night on the other. On the day side, temperatures exceed 2,400 degrees, 4,350 degrees, hot enough to vaporize metals like iron. But that's not all. Powerful winds blowing at hundreds of kilometers per hour carry this vaporized iron to the cooler night side. There, the metal condenses and falls as rain. Imagine droplets of molten steel falling from the sky, scorching everything they touch, if there were anything there to begin with. What happens on WASP-76b resembles the forge of a blacksmith, a place where a steel storm not only scorches the surface, but reshapes the landscape with each atmospheric outburst. HD YT9733b, glass storms. On this exoplanet, weather is the definition of destruction. HD 1189733b, located about 63 light-years away, is infamous for storms that outmatch the worst disasters on Earth. Winds on this planet reach speeds of 8,700 km/h, 5,400 mph, nearly 7 times faster than the strongest hurricanes on Earth. But that's not all. Instead of water, the planet's atmosphere contains molten silicon. When it cools in the air, it forms tiny glass droplets that rain down at bullet speed. Imagine a storm where the sky literally tears everything below to shreds. Every drop acts like a razor-sharp needle, destroying everything in its path. It's a place where umbrellas wouldn't just be useless, they'd be meaningless. Maybe we should stay on Earth. So, what do you think? Do you see how extraordinary Earth's rain really is? It doesn't burn, doesn't eat away at us, doesn't turn into diamonds or fall at hurricane speeds. We might sometimes dislike it, but it's the reason life exists. Rain on Earth is a gift, and in the cosmic scale of things, an incredibly rare one. Next time it starts to rain, maybe take a moment to look at the droplets with a bit more gratitude. It could have been worse. It could be liquid iron or sulfuric acid. Don't forget to click subscribe so you won't miss the next episode. We've got plenty more fascinating stories to uncover. Thanks for joining me. See you in the next video.